right, I have been trying to get the grade book upgraded this morning. I'll get it done by the system. Time in the afternoons over here. Before I go home today, I will have the grade book updated on what you have completed so far in Go Formative. I've already gone through the first couple of lessons just to make sure I've caught up on anybody, but I will get all the way through yesterday's lesson upgraded by the end of today. So I'll have that up there for you. So you'll be able to check your grades for advisor tomorrow, and that'll be as current as it can. Anything you're doing from this point on the rest of the day, I probably will not have upgraded in the grade book, but I'll get everything that's done as of right now. We get everything as of right now updated by the end of today. So this week, we'll see. You should have 5 assignments done in formative, including the quiz. There was a quiz and 4 other assignments. This week, we're not going to have a new lesson. We're stopping our lessons and doing a performance task. This is where we take what we have learned the last several lessons and we apply it into a real life situation. So this week, let me show you what we have in formative. Put this up on the screen for you. You have something called a bee colony performance task. Bee colony performance task. So here's what it is. It says use this scatter plot, and here's the link. So let's click on the link and look at the scatter plot. Okay, here's the data. This says this is honeybee colonies in California from 1939 to 2013. So this is the number of colonies of honeybees that were being kept by individuals for that long period of time. So here's all the data. There's 56 more rows that are hidden. So if you want to see all the data, you got to click that little button because it kind of abbreviates it for you. But over here is the graph of all the data that's on that table. All right, so you see all of this information. So using that graph, here's the question. It says, based on the scatter plot, explain why a quadratic function might be an appropriate model for the population of honeybees in California. So looking at that, you have to explain why a quadratic model might be appropriate. Okay? Then determine a quadratic. It tells you right here to use a quadratic. Determine a quadratic regression equation that models this data. Round it to 3 decimals. Okay? Because it'll give you more than 3 decimals. So remember, that's when you do that equation. That's y1, y1, and you have to use that tilde and then put a quadratic using x1 over here, quadratic, right? So you'll do that. And then use your equation or the graph, because the graph's a lot of time easier, to predict in what year the number of colonies will go to 0. Because if we look at it, it's going down, right? And so your quadratic equation is that graph is going to hit 0 somewhere down here. And if you look at the graph and find out what year it hits 0, that's the easiest way. Otherwise, if you use your equation, you have to set your equation equal to 0 and solve for x. So you can do it either way. Set your equation equal to 0, solve for x, or look at your graph that you're going to create, that regression equation, to see what year it hits 0. So number 4 says, does your function appropriately model the data set and justify your response? So in other words, in real life, using your model, is that really accurate on what do you think is going to happen with the bees? Are they going to hit 0 by some year or something? Because look at the model, using your equation. Do you think that's real world, that's how that should happen? At some point, there will be no bee colonies in California. Okay, so after you finish this one, hit next. And over here, now you get to break it up a little differently. Separate the California honeybee colony data into 2 sets so you can use 2 different functions, right? So you're going to break this up to where it's 2 different tables. 2 different tables. And then use 2 different functions. Now, you can use the same kind of function. If you want them both to be linear, both to be quadratic, both exponential, you can do them both the same, but they would be 2 different equations. So when you break this up, you figure out where do you want to split the data, and you make it into two tables. So I gave you all of the tables right here because you may need to retype them into Desmos because it'll be hard to separate all of this data into two on Desmos. You'll need to retype a new table. So you'll have two different tables that you'll do this for. And you decide, looking at your data, looking at the graph, where you want to split it. Right? So that's going to be however you want to justify it. So what this one is, explain how, it has it up here in red, explain how and why you separated the data the way you did. So as long as you can justify why, there's no wrong answer here. If you can't justify it and say, I just split it here, well, that's not good. You have to explain how and why. So as long as you explain how and why, there's different ways to split that data. You can decide how to split. When you look at it, you make a good thing in your head. All right, how would I want to split that? Where would I want to split that? What year would I want to make the first year of the second one as opposed to the first one? All right, so you can look at that and decide that. So after you do that, describe the type of function that you can use to model each of the two data sets. And like I said, you could use the same type of function for both of them if that's appropriate. Maybe you want to make them both linear. And then determine a regression equation for each part. Now you're going to do two different equations, one for your first table, one for your second table. Enter your first one right here, enter your, there you go, and enter your second one right here. That's going to be your two different regression lines based on however you split the data in half. Then I want you to describe the similarities between the quadratic model that we made on the first part and then the two that you made after you separated it. Describe how they're similar. You know, what's the similarities? And then number 10, how does your two models address your concerns about how appropriate the quadratic was from number 2? Because back here, you had to answer, does the function appropriately model this? Right? This equation you made right up here in number 2, we answered, is that appropriate? Is that really how the bees population is going to be? So in number 10, you talk about how separated the two models, how does that help the concerns you had back in number 4? So think about that when you're answering number 4. Obviously, there's some problems with the quadratic model that you see in there that you think may or may not be realistic to real life. So your two models, when you split that into two pieces of data, may be more accurate, may help better reflect what's probably going to happen with the bee colonies going forward, as opposed to just the quadratic model. Because obviously something's going on with the bee colonies here. Things have changed, and we need to figure that out. So in Google Classroom, let me show you what I have in here for you. In Google Classroom, we have the performance task instructions, right? Oh, where's that? Performance task instructions right there. When you open this up, it gives you two videos you can watch in here. Why are bees important? Right? So if you're not aware of how important honeybees are to just life in general, that honeybees are required for us to live, here's a video that'll help explain that. And then what's going on with the bees? Right now, there's a worldwide bee problem. And there's a video that talks about that, what's going on with the bees. So those videos will help you. If you need a refresher on how to make the regression lines in Desmos, this is here in your instructions also, so you can click on that video and get that. But here is information, modeling the bee colony collapse. This talks about what's going on, and it says there's 20 points available for this. So this is the one-page instructions with a few videos that you can watch. So after that, then you go to the bee colony, and this is parts 1 and 2. Parts 1 is using the data as it is. Part 2 is splitting it into two pieces of data. And we're not done with this. We're going to come back and do another part of the performance task probably next week. So again, it's informative. 10 questions worth 20 points. You need to be sure to answer the questions. When it says describe, don't just give me 1 or 2 words. Describe. Talk about it. Give me some sentences. How do the models address your concerns. Give me some sentences. Make sure you get your regression lines, and you make them however you think is appropriate when you break your data into two. And again, there's all the data, because you may need to make new tables. So that way you've got all that information to get that done in Desmos. So, all right. Any questions on that? Gosh, class is so much shorter this week because I don't have a new lesson to present to you. Just a performance task where we're taking what we've learned and we're applying it in a real life situation. This is actual data of the bee colonies in California. So, all right. If nobody has any questions, I'll let you go. If you're behind, your grade's below 70% on Wednesday, I'll see you then. Otherwise, I'll see you next week.